In definitions in Article 100, we find out continuous loading or continuous duty is described as anything that runs for 3 hours or more continuous. Turn to 210.19, A1A. It notably gives us a percentage of increase. It tells us where a branch circuit supplies continuous loads or any combination of continuous and non-continuous loads, the minimum branch circuit conductor size shall have an ampacity not less than the non-continuous plus 125% of the continuous. So in layman's terms, what it is telling us is that when we run something for 3 hours or more, we are to increase our conductor in text by 125%. Mathematically, 1.25. In layman's terms, we need to make this 25% bigger. And this element of thought is very important for electricians. Because in our fundamentals, we learned this morning that we have one problem: heat. And you're going to find out that 90% of this book is nothing more than the control of heat. And we only have 2 ways to get rid of it. Absorb it, which is done through the use of your conductors, or spread it out with your enclosures. This is my panel board, or my MDP, or my switchboard. One guy in class said, "No, Vic, that's a door." I went, "That's where we're at now, right?" This is my enclosure. It's why we build them out of premium carbon nickel steel and have not migrated to newer material. Nothing spreads heat out more evenly than premium carbon nickel steel. And then we tie them all together with bonding jumpers, which gives them a continuity so that when the MDP starts getting excessive heat, it'll jump on that bonding jumper and go to the switchboard. And from the switchboard over to the panel boards. And so we get uniform dispersion of heat. Plus, carbon nickel steel is highly magnetic, and we work with an electromagnetic force, so that works in our favor. 2 birds, 1 stone. You call this a conductor. Victor calls it a heat sink. That was the beauty of alternating current that Tesla introduced us to. DC only moves in one direction. You've all looked at DC systems. Got to have a fuse on the equipment, got to have fuse in the beginning, got to have a fusible link on the conductor. It's because it all moves in one direction. And if there's any heat point or stress on it, guess what? If you don't have that covered, you vaporize that conductor, or you burn up that piece of equipment, or you melt that fuse link. Not alternating current. It moves in both directions. I stumbled onto a video here a while back. I gotta find it again. This guy on YouTube had taken a slow motion camera and set it up with a conductor so you could actually see the electricity move back and forth for alternating current. And that's the beauty of alternating current. It's moving at light speed, and at 60 hertz, it's actually moving in both directions in oscillation, which gave us the ability to have single point protection. We didn't need all those fusible links. We didn't need all these fuses everywhere. We could go to a central distribution, hook a conductor up, go to a piece of equipment, turn this on, and now, through alternating current, it would read that loading and bring that heat signature back to this device while still supplying that machine, which was why it was so brilliant. We could then go to centralized distribution with centralized protection and now physically measure the heat of loading on this, and it would bring that signature of heat back to this and still supply the load to the machine. Brilliant. So we find out the first level of heat shows up. Your heat sink needs to be 25% bigger to absorb that amount of heat. When you go back into this code book, into your equipment, and it says that piece of equipment needs 300% of inrush current, you know what they're telling you? That's their gauge for heat. They're saying now, that nameplate says you need 80 amps, but 300%, that means you take 80 amps times 3. Because the amount of heat generated by that machine, I need a conductor, even though it's carrying 80 amps, that will be good for 240. I'm absorbing heat. That's why all the time when I look at equipment, I've got a lot of entities that'll ask me to come look at new equipment because that's sort of my forte, bonding and grounding and installation. So they're always wanting me to come look at new stuff. You go, what do you think? I'm like, that's pretty cool. Wish we'd had that about 40 years ago. But then they'll say, well, you know, that thing needs 300% inrush current. What do you think of that? And I go, yeah. They go, well, we thought that impression. I go, nah. They go, well, what's it mean to you? And I go, well, that's a lot of heat. Because that's all it means to me. I'm an electrician. Because if I get it wrong, first thing that goes is my insulation. If I get it really bad wrong, I can vaporize this conductor, can't I? Which is why we have to understand we have a single problem, heat. We only have 2 ways to get rid of it. We're not NASA. Absorb it with your conductors, spread it out with your enclosures. And so this is why when we begin to look at this information, it begins to make sense. Because 210.19 is now that text that supports that. First level of heat, by definition, is going to show up in 3 hours. So guess what? Make your heat sink 25% bigger. Thank you for watching our video. This was a sample of our paid training. If you're looking for someone to provide you with exam prep, or you're just looking for continuing education hours, go over to jcrproductions.com. We would love to see you in class and provide you with all the things you need for a professional electrical education. We're looking forward to seeing you in class.